Hi, boys and girls, and welcome to our very last virtual field trip of the school year. I am really excited for this one. It is going to be out of this world. Let's get ready to go to outer space. And I think I have to move my camera here. I'm going to disappear, but we are going to be here. So not very long ago, there was a space launch to the International Space Station. It happened not this past Saturday, but the Saturday before. Let's take a look and a listen.
3, 2, 1, 0. Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA. Go SpaceX. Godspeed. Bottom dog.
So SpaceX just launched NASA's astronauts into space for the first time. The mission, called Demo 2, is technically the final test flight of the company's Crew Dragon spacecraft. It's also the first launch of NASA astronauts from U.S. soil since 2011. SpaceX's Crew Dragon capsule is carrying NASA astronauts Bob and Doug. And that's them. They're sitting in the flight deck. The Crew Dragon is the first privately developed spacecraft to bring people to the International Space Station. You'll also hear this called ISS. The spacecraft is designed to carry 7 people and has a system of controls focused around touch screens. It's also carrying 2 payloads, one being an art collection based on space travel, and the other payload is a photo of the 2020 graduates shaped as planet Earth. So each one of those squares is a photo. It also landed its Falcon 9 rocket booster on the company's barge stationed in the Atlantic Ocean.
And there you can see on your screen, Falcon 9 has landed. This is the first Falcon 9 to carry humans to orbit, so very exciting for us.
Demo 2 represents the final step before NASA certifies the SpaceX capsule to fly regular missions to the ISS. After those missions begin, SpaceX plans to use Crew Dragon spacecraft for other missions, including space tourism. NASA hopes to save money by using SpaceX to send astronauts to the ISS. The agency expects to pay $55 million per astronaut to fly with Crew Dragon, as opposed to $86 million with Russia. They had been sending all of their astronauts, our astronauts, over to Russia to get to space before. And now we can do it from our soil. So you might be wondering a little bit about what the International Space Station is, and I found a tour of the International Space Station.
Have you ever been on a really long trip and it felt like it took forever to get where you're going? Well, how would you like to take a long trip into space? That might sound like something you've read about in a book or seen in a movie, but for a select few people, it's real life. I'm talking about the astronauts who live in space for months at a time on the International Space Station. The International Space Station, or ISS for short, is in orbit above Earth. Astronauts live and work up there doing science experiments and learning about life in space. To get there, astronauts are carried up into space by rockets, and when they go home, they ride in space capsules that fall back to Earth. Let's take a closer look. Those big flat shiny things are solar panels, and they provide energy for the space station. They capture sunlight and they turn it into electricity. The space station uses that electricity to power lights and computers and everything else that makes the ISS go. This is a robot arm. Astronauts inside the station use this arm by remote control to fix things on the outside of the ISS. Although it might not look like it, the space station is kind of like a big house. It has 5 bedrooms, 2 bathrooms, a kitchen, which the astronauts call a galley, and they even have a laboratory, just like we do in the fort. But as you can imagine, life on the space station is a lot different than it is back home on Earth. For one thing, All of the water that astronauts use has to be flown up by rockets. Since it's so hard to get up there, water is only used for drinking and eating. So astronauts don't take baths or showers with water. Instead, they wash up with special washcloths. But probably the biggest difference is that there's much less gravity up in the space station than there is here on Earth. Instead of sticking to the ground like we do at home, astronauts up there just float around. So, in a way, it's a lot easier for the astronauts to move around because there's less gravity, but after a couple of days in space, their muscles actually get weak. So astronauts on the space station have to exercise at least 2 hours every day to give their muscles a workout. But the rest of the time, the astronauts are conducting experiments. They'll study plants to see how they grow in space, and they'll study small animals like fish to see how their muscles do in low gravity. They even study how robots work in space. Say hello to Robonaut 2. He's a robot like Squeaks who lives on the space station full time. He's on board so astronauts can see if robots work as well in space as they do on Earth. R2, as his friends call him, can use tools and even go on a spacewalk by himself. Spacewalks are when astronauts leave the space station in a spacesuit to do work on the outside of the station, but they don't do them very often. Spacewalks are only for when astronauts need to fix things on the ISS or to gather information for experiments. So, life on the International Space Station is hard work, and it's really different than life at home. But if you ask me, the astronauts who get to go there are pretty lucky because they actually get to live in space. Thanks for joining us on SciShow, kids. Maybe one day if you work really hard, you can go to the ISS. See you next time.
So we might be wondering, what else is in our solar system? Have you ever wondered why it's called the solar system anyways? I'll give you a hint. Solar has a special meaning. Let's take a look.
Our solar system. Have you ever looked up into the sky and wondered what was there? Higher than the birds, past the clouds, and farther than the moon, a whole host of fascinating objects spin in outer space. Let's imagine for a moment that we can leave the Earth behind and explore the solar system that surrounds it. We call it the solar system because everything in it is centered around the sun, and solar means something to do with the sun. The sun is a star, just like many of the stars that you can see in the night sky, just many times closer to us. Still, the sun is very, very far away from the Earth, almost 93 million miles away. That's why it looks so small, even though it's the biggest object in the solar system. In fact, the sun makes up more than 99% of the mass in the solar system. If you put all of the planets, moons, asteroids, comets, and everything else in the solar system together, they would make up less than 0.25% of it. The sun is so big that it's more than 100 times wider than the Earth, and if it were a giant jar, you could fit more than 1 million Earths into it. More than that, the sun is what holds the solar system together. Its massive gravity is what keeps the Earth and all the other planets circling around it instead of drifting off into space. The sun is also what allows us to live on Earth. Without the sun, there would be no heat. There would be no light. Plants could not grow. Water would freeze, and nothing could survive. The sun gives us heat and light because it is always burning. It is a giant ball of gas, mostly hydrogen and helium, and it burns at millions of degrees in its center. Let's leave the sun now to explore the planets. As we move away from the sun, the first planet we will encounter is Mercury. Mercury is the smallest planet in the solar system, much smaller than Earth, and one of only 5 planets you can see from Earth using nothing but your eyes. Of course, it won't look much like a planet. It looks more like a bright star, and many nights you can see it close to the horizon near sunrise and sunset. Mercury is a lot like our moon. It's small and has a rocky surface with craters on it. It has no moon of its own and no air to breathe. You probably wouldn't enjoy a visit to Mercury, since temperatures are boiling hot in the sun and freezing cold in the shade. Something interesting about Mercury is that it is the fastest planet to go around the sun. It only takes 88 days. Next is Venus, the second planet. Some people call Venus Earth's sister because the two planets are very close in size and gravity, but they are very different on the surface. First of all, it is very hot. Venus is the hottest planet in the solar system. It's not as close to the sun as Mercury, but its thick atmosphere of carbon dioxide helps it to trap the heat and stay warmer than its neighbor. It has a thick atmosphere, but it is not one you could breathe. It is mostly made of carbon dioxide, and there are clouds of sulfuric acid. Venus might not be fun to visit, but it is beautiful to look at. It is the second brightest object in the night sky. The only thing brighter is the moon. If you are looking at a sunrise or a sunset and suddenly notice what looks like a very bright star, you are probably looking at Venus. After Venus comes Earth, the third planet from the sun. Of course, you know all about Earth because that's the planet where we live. Earth is what's called a Goldilocks planet because it's not too hot and not too cold. It is just right. As far as we know, Earth is the only planet to have living things. Let's leave Earth again for a moment, though, and visit Mars, the fourth planet from the sun. Mars is known as the red planet because iron oxide, a material like rust, in the soil gives it a reddish color. Mars is smaller than Venus and the Earth, but larger than Mercury. It is cold and rocky, with a thin atmosphere made of carbon dioxide and oxygen. There is water ice on Mars. Scientists are very interested in Mars because they think that people could live there with the help of some special equipment. Rockets and probes have already been sent there to gain more information about the planet. Right now, there are 2 special robots exploring the surface of Mars, sending information back to Earth. Mars is the first planet we visited today besides Earth to have its own moons. It has 2, although they are not big and round like our moon. Mars's moons are small and irregular. Scientists think they may be captured asteroids. Maybe they came from the big asteroid belt that is between Mars and Jupiter. An asteroid belt is a big ring of asteroids, or rocky objects, orbiting the sun. Jupiter comes next, the 5th planet in the solar system. Jupiter is the largest planet and is something called a gas giant. It is called this because it is really big and made mostly of gases. Jupiter is so big that you would have to place 11 Earths end to end just to stretch across its middle. Jupiter is also the 3rd brightest object in the night sky. Only Venus and the moon are brighter. You can usually find Jupiter higher in the sky than Venus, since Jupiter is away from the sun and not towards it. Jupiter has at least 67 moons that circle around it, but 55 of them are very small, only about as big as a mountain or smaller. Some of its moons are very large, and at least 2 of them are about the same size as the planet Mercury. One of its moons is the largest moon in the solar system. Some of these large moons can be seen from Earth in your backyard with a telescope. People cannot land on Jupiter because it is made of gas. There is no ground to land on. Even if there was somewhere to land, Jupiter is covered by terrible storms, much stronger than even the strongest storms on Earth. One storm that we know about can be seen from Earth. We call it the Great Red Spot because that's what it looks like, and it has been going on for at least 200 years. After Jupiter comes Saturn, another gas giant. Saturn is famous for its beautiful rings. Although they look solid from a distance, the rings are actually made from many, many small ice particles, as well as rocks and dust. Saturn also has more than 60 moons orbiting around it, some as large as the planet Mercury, and many smaller. Something interesting about Saturn is that even though it is very large, it is not very dense. That means that if you could find a bathtub large enough to put Saturn in, it would float instead of sink. Saturn is the farthest planet that can be seen from Earth without the help of a telescope. After Saturn comes Uranus, the seventh planet from the Sun. Uranus is another gas giant, but it is much smaller than Saturn and Jupiter. Unlike any other planet in the solar system, it is tilted so much that it actually spins sideways. Uranus has rings around it, although they are much smaller than Saturn's, and 27 known moons. Uranus is covered in blue clouds made of methane, which give it its lovely color. Very similar to Uranus is Neptune, the eighth planet from the Sun. Neptune is another gas giant, and like Uranus, it has methane in its atmosphere, so it also looks blue. Neptune is a darker blue than Uranus, and scientists aren't sure why. Neptune has a few thin rings and 14 moons that we know about. Because Neptune is so far out in space, it takes it a very, very long time to go around the Sun. Remember Mercury, that only takes 88 days to go once around the Sun? Poor Neptune takes over 164 years to finish an orbit around the Sun. The last time that Neptune was in the same place it is now was before the American Civil War, before computers, phones, airplanes, or cars had been invented. Neptune has the longest orbit of any planet in the solar system. Now you may think that I've forgotten someone. Pluto. Pluto was discovered in 1930 and was listed as the 9th planet in the solar system. As it was studied longer, scientists realized how small it is. It is much smaller than any other planet in the solar system, and even smaller than many other moons. Plus, people started to discover other small, rocky planet-like objects in space near Pluto. Some of them were even bigger than Pluto. In 2006, after 76 years being listed as a planet, Pluto was declared a dwarf planet to show that it was something that was like a planet but much smaller. There are at least 6 dwarf planets in the solar system, and possibly many, many more. That leaves us with 8 official planets in our solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. I hope you enjoyed exploring the solar system with me today. Goodbye till next time.
So we heard a lot about the moons that some of these planets had. So I thought we should go explore our moon.
Over 150 moons orbit the solar system's planets, and one of those moons calls Earth home. The moon was formed about 4.5 billion years ago, when, according to one theory, the Earth slammed into another early planet. Debris from this collision began to orbit Earth and accumulated, forming today's moon. The moon is the 5th largest natural satellite in the solar system with a diameter just under the width of China. It's composed of an iron-rich core, plus a mantle and crust containing minerals made of magnesium, oxygen, and silicon. The moon's surface was once geologically active and covered in an ocean of magma. But today, apart from traces of water ice, the surface is completely covered in dust and rocky debris. Countless craters dot the moon's surface, each formed by objects such as meteoroids, comets, and asteroids crashing onto the moon. The largest crater, the South Pole Aitken Basin, spans across a quarter of the moon's surface and is nearly deep enough to fit Mount Everest inside. The moon orbits our planet at an average distance of 30 Earths. It rotates at the same rate that it revolves. So as it revolves around our planet, the same side of the moon faces the Earth at all times. From the Earth's surface, we can observe 8 distinct traditionally recognized stages of the moon's illumination. Called lunar phases, they have been observed for thousands of years and even provided the basis for the earliest calendars. For most of human history, the moon could only be studied from afar. But on July 20th, 1969, humans were able to close that distance with the American spaceflight mission Apollo 11.
It's one small step for man, one giant leap for mankind.
It placed humans on the moon for the very first time, bringing our understanding of Earth's only natural satellite one step closer.
So they got me thinking, what would happen if we didn't have the moon? Well, this video is going to show us what would happen.
I am over the moon to be answering today's question. In fact, it's sending me positively loony. Sorry, I shouldn't wax on, should I? The concentration's probably waning. Enough. No more terrible puns. That was a rocky start. This film is about our nearest celestial neighbour, none other than Luna, our very own natural satellite, the moon. It's the Earth's constant companion, orbiting our planet once every 27.32 days, its phases marking the passage of the months. But is the moon any more than just a very rough calendar? Do we really need it? And would we miss it if one day it just wasn't there? Well, there's half a chance that we'd notice it was gone after a few nights, because thanks to the reflected light from the sun, a full moon can give enough light to see by at night. So without it, we'd be left with much darker skies than we're used to, which is bad news for getting around without a torch, but great news for stargazing. Without that bright disk of the moon oversaturating our eyeballs, we would have spectacular views of the Milky Way right through the month. However, this moonless life wouldn't spell a life of leisure for the many species of animals that rely on the phases of the moon as a pacemaker for their biological clocks, like Acropora corals, who time their simultaneous release of sperm and eggs to a precise 1 or 2 days a year, when a full moon appears in the sky just after sunset. Or the streamlined spinefoot fish, which all choose to spawn during a waning quarter moon. Losing the moon would play havoc with these reproductive cycles and the species that rely on them, potentially leading to their extinction as they fall out of sync. And it's not just the light of the moon that animals rely on, but also the effects of its gravity as it progresses on its cosmic journey. Despite being only 2% of the volume of Earth and 400,000 kilometers away, that 22 billion cubic kilometers of cratered moon rock still has enough of a pull on Earth and its oceans to create our tides. Now, I'm sure this is one of the very few things that you remember from geography classes at school, up there with Oxbow Lakes, right? But let's recap. Tides form as huge masses of water are pulled towards the moon, creating a bulge on the side facing it. On the other side of the Earth, the moon's gravity isn't so strong, so the water there gets left behind, creating another bulge. Every day, most coastal areas witness 2 high tides and 2 low tides as the Earth rotates, allowing these bulges to circumnavigate the globe. No more moon would mean much smaller tidal bulges, since the distant sun would be the only body pulling on the seas. Therefore, the water would settle to create new, barely varying coastlines. Now, while most of us might feel a bit nostalgic for the loss of the tides, it's a bigger deal for all of the animals, the plants, and the human cultures that depend on them. Intertidal zones are the bands of land along every coastline that are submerged and then exposed by the tides on a daily basis. And they are an important habitat for organisms that like both the wet and the dry, like barnacles and mussels and crabs and sea anemones and seaweeds and many starfish. But the moon may be even more important than that. There's evidence to suggest that not just intertidal creatures, but all of life on Earth might owe its existence to our friendly rock in the sky. 4.5 billion years ago, when the Earth was newly formed, scientists think that it span on its axis at an alarming rate. Days would have lasted 6 hours, and the resulting Coriolis forces would have left the surface battered with intense winds and storms. But this all changed when another planet smashed into our early Earth, breaking off a bunch of bits that together formed the Luna that we know and love. With our orbiting moon in tow, the Earth experiences something known as tidal friction, where some of the Earth's rotational energy is lost as the tidal bulges move around the planet. It's a small effect, but over billions of years, it's been enough to slow the Earth's rotation so much that it now takes 4 times as long to spin all the way round. That means day and night cycles are a comfortable length, and weather systems are no longer terrifyingly strong. Longer days have made our world a much more hospitable place, and that's thanks to the moon. Incidentally, this tidal friction thing is still going on, and the length of our day continues to increase at a rate of 2.3 milliseconds a century. But in 1 million years from now, days will be an hour longer, which means an extra hour in bed. Nice one, moon. But it doesn't end there. The orbit of the moon is also critical for maintaining habitable conditions worldwide. At the moment, our planet's axis of rotation is tilted at a comfortable 23.5 degrees, meaning we have pleasantly moderate seasons. But a planet's tilt has a tendency to change, as rotating planets are affected by other massive objects in the solar system. If the axis becomes too horizontal, the Earth will literally be spinning on its side, and a northern hemisphere winter would see all of Europe, Asia, and North America plunged into a cold darkness for many months at a time. Meanwhile, the South Pole would see soaring temperatures as the sun remains high in the sky for weeks. Such massive temperature fluctuations are certainly not conducive to life, so we can thank our lucky stars that we've got our moon, whose orbital path seems to steady the planet's axial tilt, stopping it from ever straying too far and keeping conditions within comfortable limits. So, do we really need the moon? Well, none of the other nearby planets have one like ours, but then they don't have life either. Just saying. Are you loony for the moon? If you enjoyed this Earth Lab video, give us a like, let us know your thoughts as well in the comments below.
So we know that the closest star to Earth is our sun. But what could we learn about other stars?
Like fireflies on a still summer night, they gently dot and illuminate the infinite velveteen sky. Stars, be they millions or billions of years old, are all born in nebulae, clouds of dust and mostly hydrogen gas. Within these stellar nurseries, stars begin life as protostars, or hot cores formed by the collection and collapse of dust and gas. As the protostars become hotter, hydrogen nuclei inside of the cores begin to fuse and create helium. It is this chemical reaction, thermonuclear fusion, that generates a star's heat and energy and causes it to shine. Stars are categorized by a number of characteristics. One of these classifications is by surface temperature. Called spectral classes, these 7 major groups range from the coolest stars, which are designated as M, and up to the hottest stars, which are designated as O. Stars are also classified by the amount of light they emit, or luminosity. Called luminosity classes, these 9 major groups range from the small, less bright white dwarfs to the large and extremely bright hypergiants. But no matter their luminosity or surface temperature, all stars eventually burn through their hydrogen fuel and die out. Less massive stars, such as our Sun, release their stellar material into space, leaving behind a white dwarf surrounded by a planetary nebula. More massive stars instead blast matter into space in a bright supernova, leaving behind an extremely dense body called a neutron star. But the most massive stars that are at least 3 times our Sun's mass, collapse into themselves and create a bottomless well of gravity, a black hole. But from the remnants of stars, heavier elements are cast into the universe, and it is this stardust that formed the seedlings of life itself.
Which leaves me wondering, are there other planets out in space?
They are nestled in the final frontier, countless worlds, scattered throughout countless galaxies, challenge the notion that we are alone in the universe. Exoplanets are worlds that exist outside of our solar system. Also known as extrasolar planets, these bodies often orbit their own stars, with some being a part of entire planetary systems. Exoplanets are made of the same elements as the worlds in our solar system, and based on their composition and structures are just as diverse. Some, known as giant or Neptune-like planets, are large gaseous worlds. Other gas giants, called hot Jupiters, closely orbit their stars, causing the planets to have high surface temperatures. Another category of exoplanets consists of super-Earths. Smaller than the gas giants, but larger than Earth, super-Earths are terrestrial and made primarily of rocky or icy material. The final category includes Earth analogs. Much as their name implies, Earth analogs are similar to Earth in various ways, including size, composition, and distance to their home star. Exoplanets are difficult to detect directly, mostly because they are outshined by the stars they orbit. To circumvent this, about 5 primary methods have been developed to find these planetary bodies, including radial velocity, in which a planet causes a star to wobble; direct imaging, where the glare of stars is blocked in order to see objects nearby; astrometry, which observes a star's movements in relation to nearby stars; gravitational microlensing, which observes the light of a star being bent by a planet's gravitational pull; and the most prolific form of finding exoplanets, transit, the method in which a planet passes between its star and Earth, thereby dimming its star's light. Scientists have suspected the existence of worlds outside of our solar system for thousands of years, but the first confirmed existence of an exoplanet orbiting a sun-like star only occurred in 1995. Ever since, about 4,000 exoplanets have been confirmed by multiple discovery methods, with about 3,000 more awaiting verification. According to one theory, at least one exoplanet orbits each star in the Milky Way. This would place the exoplanet count in our local galaxy to about 1 trillion. The search for exoplanets continues, not just to create a catalog of known worlds, but also to see if life may exist elsewhere in the universe. Astrobiologists closely study the size, composition, and location of exoplanets relative to their stars to see the likelihood of organisms thriving in an environment other than Earth. Who knows what discoveries these new worlds could bring?
But let's not forget about our home planet Earth.
Earth, the only planet known to maintain life, a product of scientific phenomena and sheer chance. This blue speck in space holds the past, present, and future of our very existence. Approximately 4.5 billion years ago, the Earth formed from particles left over from the creation of our Sun. Gravity drew these particles together to form pebbles, which then formed boulders and eventually the Earth. At its heart is a solid inner core covered by a liquid outer core. Above this sits the mantle made of flowing silicate rocks and a rocky crust. This rocky mass is the third planet from the Sun, orbiting the star from an average distance of about 93 million miles. It's close enough to the Sun to be warm, unlike the cold gas giants, but not so close that its surface is exposed to extreme heat and solar radiation, as is the case with Mercury. Earth's unique position in the solar system allows it to house phenomena yet to be found anywhere else in the universe, particularly liquid surface water and life. According to one theory, much of Earth's water is as old as its rocks, both of which having formed during the Earth's earliest days. Because of Earth's unique distance from the Sun, the planet is able to contain water in all of its forms, liquid, ice, and gas, rather than have them permanently frozen or evaporated into space. But Earth is the only known place in the universe with liquid water on the surface, thereby having unique cascading effects on the planet. It hydrates the land, helping create nutrient-rich soil. It collects and pools to form oceans and freshwater systems. And it cycles upward to add moisture to Earth's protective atmosphere. And where there is liquid water, there is life. About 3.8 billion years ago in Earth's oceans, primitive life existed in the form of microbial organisms. They, and the ensuing billions of years, gave rise to a range of more advanced life forms that thrived in Earth's seas, lands, and skies. As the only world known to harbor life, Earth's biodiversity is expansive in nature. An estimated 1.5 million species of plants, animals, bacteria, fungi, and others have been cataloged, with potentially millions, if not billions more, yet to be discovered. Home to life and fueled by water, Earth houses a unique global ecosystem, as curious and as grand as the astronomical events that made them possible.
Well, our journey is coming to an end, and here we are back on the spaceship, about to land on Earth.
Good view of Discovery here, still 73 miles away from Kennedy Space Center and 15 miles up, traveling 1,700 miles per hour with 6 minutes to go.
So it's flying a lot like an airplane would, but just think, unlike an airplane, this spacecraft can take you worlds beyond our planet. I'm just going to speed it up just a little bit.
30 seconds until touchdown.
Put out the landing gear just like a plane would.
Main gear. Landing gear now down and locked. Main gear touchdown. Pilot Jim Dutton now deploying the drag chute. Nose gear touchdown. That brings an end to the STS-131 mission, the 131st Space Shuttle flight, and the 33rd to the International Space Station. Discovery left Florida on April 5th with 7.6 tons of new science equipment and spare parts, including equipment that should improve the station's capability for Earth observation work, equipment that could help astronauts avoid muscle atrophy and scientists better understand muscle atrophy, and equipment that will help keep the station systems cooling properly.
Remember, muscle atrophy is how the muscles get weaker
Discovery
because there's
brings
not
home with it
gravity.
the last large return load from the station, 2 tons of used equipment.
Roger, wheel stop Discovery. Welcome home. Dex, congratulations to you and the crew on an outstanding mission. There are no immediate post-landing deltas. We'll meet you on page 5-3 of the entry checklist.
Houston Discovery, thanks for those words, CJ. It was a great mission. We enjoyed it. We enjoyed working with you and all the teams in Mission Control. And we're glad that the International Space Station is stocked up again. Thanks a lot.
Well, boys and girls, I hope you had a great time. I hope you enjoyed our mission today. And remember, stay curious, stay kind, and you too can do wonderful things. Bye now.